is Dr. Rana. I'm a Vice President of Research and Apologetics for an organization called Reasons to Believe. And the title of this session is Science and Faith in Conflict. And what I'm going to argue this morning is that in spite of the popular perspective that science and faith are indeed in conflict, there's actually a very powerful case that one can make for the validity of the Christian faith from the latest advances in science. And so we're going to go ahead and take a look at how one can be both a Christian and a scientist. How can a person be a person of science and a person of faith? So let's go ahead and start the session by looking at this statement made by Alistair McGrath. Alistair McGrath, of course, is speaking here today, very much a respected theologian and a scientist as well. And in an excellent book called The Twilight of Atheism, which I strongly commend to you, McGrath writes these words as he explores the role that science has played for many people in establishing atheism as a dominant worldview. McGrath writes these words: "One of the most remarkable developments of the 19th and early 20th centuries has been the relentless advance of the perception that there exists a permanent essential conflict between the natural sciences and religion. Science is at war with religion, and that war can only lead to the elimination of religious belief as a relic of a superstitious age that is now long behind us. Science proves things, whereas religion depends on the authoritarian imposition of its dogmas, which fly in the face of evidence. To take the idea of God seriously is to commit intellectual suicide. Scientists are the Promethean liberators of humanity from their bondage to religious tradition and superstition." And so when it comes to the idea of science and religion in general, and science and the Christian faith specifically, people think about science, of course, they think about a discipline or an arena of human endeavor that is characterized by reason and logic, where scientists gather evidence and they then apply that evidence they've gathered to test theories that they think describe how the world works. Whereas on the other hand, people think of religion as being based on blind belief, uncritical thinking, dogma, superstition. And as a result of that, many people see these two arenas as being intrinsically in conflict because of, again, how people perceive science and religion in general and Christianity specifically. But it's ironic to note that there's actually a fairly high level of belief among scientists. For example, in 2009, in the summer of 2009, the American Association for the Advancement of Science, which is an organization of scientists from all different disciplines in the United States, and discovered that 33% of these members expressed belief in God, belief in a personal God, whereas 14% expressed belief in a higher power that was not a personal God, but yet a higher spiritual reality. And so this is basically saying that among scientists, at least half of those scientists have some kind of religious orientation. And so the point here is that it doesn't have to be a model of conflict whatsoever. And in fact, many scientists have figured out how to reconcile their belief as people of faith with their practice and their work as a scientist. And so what I want to do today is ask another question, and that is, how can a person be a person of faith and a person of science? And what I'm going to do is approach this from a personal perspective. I'm going to talk to you about reasons why I feel that I can comfortably be a Christian, committed deeply to the Christian faith, the historic Christian faith, and at the same time also work and live and function as a scientist. And the 2 points that I want to make this morning are these: that first, the Christian worldview is compatible with the preconditions necessary for the operation of science. So we'll talk a little bit about the philosophy of science and the relationship of the philosophy of science to the Christian faith and the Christian worldview. And then I also want to talk about how recent advances in science support the notion of Christian theism. So let's go ahead and take a look at the first point. And I'm going to argue in the next few minutes that science is impossible apart from a worldview that resembles that of the Christian faith. Science is impossible apart from a worldview that resembles that of the Christian faith. And to address that question, we need to spend a few minutes talking about, first and foremost, what science is. Now, if you're a philosopher, you know that this is an incredibly difficult question. There are literally significant debates taking place at a very high academic level in terms of trying to define what exactly science is and what it isn't. And I'll leave that conversation to philosophers, but as a scientist, this is what I think science is. It is first and foremost a process by which we learn about the facts of nature. So for some people, science is simply a discipline that gives us information about the facts of nature. But more fundamentally, science is really, at the end of the day, a methodology. That really is what ultimately defines the practice of science, is its methodology, which many people believe that if you practice in a rigorous manner are going to reveal to you facts about nature. So let's focus on the methodology, because for scientists, this is really, I think, what defines science. And the methodology should be very familiar to all of you. I'm sure you've learned this somewhere along the lines in your education. Science is a methodology that essentially is predicated on making observations or performing experiments and then carefully examining the results of those experiments with the idea that these observations and experiments are going to lead to what scientists would call models. Hypotheses, theories, models. These are more or less interchangeable terms that basically describe something about the world that we live in or phenomena within the world that we live in. And then that model, if it's a good model, will lead to predictions about what we should discover if indeed that model has validity. And then we do experiments or we perform observations to evaluate that idea. That is essentially how science operates. So it very much is based on, again, reason and logic and evidence and testing, as most people would perceive. But what's important to note is that all of this is ultimately predicated on certain assumptions that you make as a scientist going into the laboratory or going out into nature making observations. And these assumptions are these: that first, the universe is real, that we assume that the universe is not an illusion, okay, but that it's a real entity, and that phenomena within the universe are real entities, and that the universe has some kind of value that would compel us to study the universe, that it's a worthwhile endeavor to learn about the universe, or again, phenomena within the universe. This is now where things become even more important in terms of presuppositions. We assume that the laws of nature exhibit order, patterns, and regularity, because if they didn't, then you could not characterize anything about the universe with any kind of confidence. That is, we would not know if what we observe and expect to happen today is the same thing that happened yesterday or will be the same thing that happens tomorrow. So we assume that there is an order, a regularity, that there are patterns in nature and that we can discover those patterns and that they are the same throughout time and throughout location in the universe. Science is impossible if these are not valid ideas. We also believe that the universe is intelligible, that we can actually learn something from the universe, and that we have a capacity within the human makeup, within our cognitive framework, to actually understand the universe in a reliable way. That not only is the universe intelligible, that it lends itself to investigation, but also that we have the mental apparatus to discern things that are real and true about the universe. Now, these preconditions have to emanate from something that we would call a worldview. And again, many of you probably are familiar with this term, but in case you're not, a worldview as defined by the late philosopher Rana in his book Faith and Reason, and that's another book that I would highly commend to you, he defines it this way: as a conceptual scheme which we consciously or unconsciously place or fit everything we believe and by which we interpret and judge reality. A worldview is essentially a set of beliefs. It's an intellectual framework where we ask certain questions and answer those questions. These are fundamental questions, and based on how we answer those questions, we have this framework by which we then evaluate everything and make sense of everything that we see. And there's a Christian worldview. There's a worldview that Christians uniformly possess that is derived from Scripture itself and from theological ideas that are part of Scripture. So, for example, as Christians, we believe that the universe is real because God created the universe, and the universe exists independently of this creator, but it is a real thing put in place by the creator. So in contrast to certain Eastern religions that think of the universe as illusory, as Christians we believe it's real, which is very important in terms of then even beginning to think that it's worthwhile to study. We believe that the creation that God put in place is good, and that God is revealed in nature, and therefore creation is worth studying because it's going to reflect to us elements of the Creator's character. We're going to see God's glory and grandeur and majesty, His righteousness, His love, His faithfulness from the record of nature. This is what Scripture tells us. So this is motivation for us to study nature. It's worthwhile studying for that reason alone. We also believe that God, who is a righteous God, is a God of order, a God of regularity. We believe that God is a God of providence. That is, once the creation was put in place, that God then ordained certain processes and laws in order for that creation to be able to sustain itself. And so again, we believe that the laws of nature are real and that they are constant. That what we learn about the universe and the world that we live in is going to be true tomorrow just as it is today and was yesterday. And because God is a God of providence, then nature is going to operate in a regular, orderly manner. Otherwise, the creation could not depend upon that providence in order to sustain itself. We also believe that human beings are made in God's image. And because we're made in God's image, we have this ability to understand that which God creates. We believe that human beings being made in His image have dominion over the creation, not that we are to exploit the creation, but we are to be stewards of the creation, and we are to use the creation to help establish human civilization and to take care of each other. And because of that, again, that motivates us to study nature. So the fact of the matter is a Christian worldview is fully compatible with the preconditions needed to do science. In fact, historians of science, at least some have argued that it's the Christian worldview that ultimately led to the birth and the flourishing of modern science in Christian Western Europe. Now, what about naturalism? Atheism, materialism, the idea, as Carl Sagan, the late Carl Sagan said, the cosmos is all that there was, is, and ever will be. The idea that there is no reality beyond the physical material universe. It's the sum total of reality. There is no supernatural. There is no God. Is that worldview a worldview that will produce naturally in an organic way the conditions needed to do science, the assumptions needed to do science? Well, I don't think that's the case. For example, if you are someone who thinks the universe is a brute reality, why would you necessarily think that the laws of nature are going to be uniform and regular, that there are patterns in nature? Why not a chaotic universe? That is just as reasonable as thinking that there is a universe that would be a universe of order. If you think that the universe has purpose, a logical extension is that there's order and regularity. If you think the universe is a brute reality and there's no purpose, why do you think that there are regular laws of nature that conform to patterns? Perhaps even more problematic is this. If you are a materialist, if you are an atheist, and you believe that the human mind is ultimately the product of undirected, blind, evolutionary processes, why would you think that your sense organs are going to give you any kind of information that is reliable about the universe? Because all that evolution requires is that our perceptions are good enough, or give us information that is simply good enough for us to survive. It doesn't necessarily guarantee that what we learn as we perceive things has any relationship to reality or to truth. So, in other words, why do we think our cognitive senses are going to give us something that information that is real, that is real and true about the universe? And why do we think that our minds are capable of rationally deliberating once we have that information in a way that produces reliable outcomes? In fact, Charles Darwin, in a letter written in 1881, privately expressed this concern. With me, the horrid doubt always arises whether the convictions of man's mind, which has been developed from the mind of lower animals, are of any value or at all trustworthy. Would anyone trust in the convictions of a monkey's mind if there are any convictions in such a mind? And so this is really a fundamental problem if you're a naturalist, is that naturalists do science, atheists do science. In fact, they co-opt science as a way to argue for their position and to criticize the Christian faith. But the fact of the matter, I believe, is that when atheists engage in the enterprise of science, they actually are stealing ideas from the Christian worldview and appropriating them to justify the enterprise of science. And then what they do is they are sawing off the branch of the tree on which they're sitting. So the fact of the matter is, if you're a Christian, science is a natural outworking of your faith, of your worldview. It's something that belongs completely and entirely to the Christian faith. So as a scientist, my worldview orients me to do science. Now, I'm also going to argue that recent scientific advances support Christian theism. And to do this, what I'd like for us to use as a framework are the classical arguments for God's existence. These are arguments, of course, that philosophers have developed in which the attempt is to argue for the rational basis for God's existence based on philosophical principles. And the two arguments we're going to focus on are the cosmological argument and the teleological argument, and I'll explain what those arguments are in just a minute. Let's take a look at the cosmological argument. This is an argument from beginning or first cause. If something exists, it must have a beginning or it must have a cause. That's the cosmological argument. And what philosophers have done over the centuries is tried to develop a philosophical argument to demonstrate that the only rational position is that we live in a universe that must have a beginning. And if the universe has a beginning, there must be a cause that exists outside the universe, and that first cause, the argument goes, would be a creator, would be God. That's the cosmological argument. Well, what's exciting to me is what astronomers have discovered. Over the last century, some of the most important discoveries have happened in the last decade or so, in which cosmologists have demonstrated that the universe has a beginning, that matter, energy, space, and time have a beginning. It's known as a singularity. The universe didn't exist and then it existed. Everything that defines the universe came into existence. This is embodied in what's known as Big Bang cosmology and the space-time theorems of general relativity. George Smoot, who was an astronomer who headed up an experiment known as the COBE experiment, in which these scientists were measuring cosmic background radiation and the structure of the cosmic background radiation, discovered the most compelling evidence that indeed the universe has a beginning. And George Smoot won the Nobel Prize in physics for heading up this work. And George Smoot, when he announced these results, said, "What we have found is evidence for the birth of the universe. It's like looking at God." And so the discoveries of cosmology demonstrate, again, the validity of the cosmological argument in a very powerful way. And so again, if you're a Christian and you see things like a beginning to the universe, this is fully compatible with the Christian faith. Now, there are astronomers today and astrophysicists and cosmologists who argue that really our universe is just a small part of a much larger multiverse, which is a reality in which there is this entity that just spawns universes willy-nilly, and that we're just one of a near infinite number of universes. But if you actually look at these models, I'm a biochemist now, I'm not an astronomer or an astrophysicist, but I do work with two astronomers. And they tell me that when you look at these different multiverse models, one thing that they cannot get away from is a beginning. That all these multiverse models require a beginning as well. So the fact of the matter is, you cannot escape the fact that everything that exists had a beginning, that came where all reality came from essentially what appears to be non-existence. And that to me is very powerful evidence that there must be a transcendent cause to the universe that I, as a Christian, would understand as God. Now, what about the teleological argument? This is the argument from design, that the universe and phenomena within the universe appear to be designed, therefore there must be a mind that's responsible for that design. And again, what astronomers and astrophysicists have discovered is that the fundamental parameters, constants, and characteristics of the universe have to be exquisitely fine-tuned in order for life to be possible in the universe. This is called the anthropic principle. And that fine-tuning of these constants, which in some cases is extreme, again, suggests to many people that our universe looks as if it's been designed. It's been designed by a mind, and that the universe indeed has a purpose, and that purpose appears to be the advent of life. And this is an incredibly important argument for, again, God's existence from design, but you can see from cosmology and from astronomy that you have two very powerful arguments, that the universe had a beginning and that the universe is designed, and so the cosmological and the teleological arguments work hand in hand based on the advances that we see, again, in astronomy and astrophysics to suggest that the Christian faith is indeed a credible faith from a scientific perspective. Now, I'm not an astronomer. Again, I'm a biochemist. There's an excellent book that I would commend to you called Why the Universe is the Way That It Is, written by my colleague, Dr. Hugh Ross. Another book that's an excellent book for you to take a look at is Creator and the Cosmos, also written, again, by Hugh Ross, which gives a lot of details. So what I'm just doing this morning is just whetting your appetite, hopefully, for you to do a little bit more study on your own. These two books are highly accessible, and we didn't bring any with us to the conference today, but if you go to our website at reasons.org, you can get a hold of these books, or you could go to Amazon or some other place as well. Now, what I'd like to do in the bulk of the time that I have for my presentation is talk about the design that I see as a biochemist. This is what convinces me as a biochemist that indeed life stems from the work of a mind. Fundamentally, that life stems from the work of a mind. In fact, I came to the Christian faith because of the evidence that I saw for design in terms of the way that biochemical systems are put together. I didn't grow up in a Christian home. I didn't have Christian influences growing up. The home that I lived in my parents had a fairly negative view of the Christian faith. As an undergraduate student studying chemistry and biology, I had professors that were atheists, and I felt very comfortable in an environment that connected atheism with science. Now, if you ask me, did I believe that God existed as a young man, I probably would have said yes, interestingly enough, but in a practical sense, I didn't really care if God existed or not. I was an agnostic. But yet when I went to graduate school and I began to study biochemistry, I became very quickly confronted with the complexity and the elegance and the sophistication of biochemical systems. And I began to wonder, where on earth do these systems come from, and how do scientists account for them? And as I looked at the different explanations that scientists offered for the origin of biochemical systems from an evolutionary perspective, this would be called a chemical evolution or abiogenesis or the origin of life problem, I found those explanations to be woefully inadequate. And at that point, I became convinced that there indeed had to be a mind that was responsible for everything. And this then led me on a journey that ultimately culminated in my conversion to Christianity. But I won't get into that, but the point of the matter is, I went from a position of agnosticism to one in which I believed there had to be a mind because of biochemical design. And I think that design is incredibly powerful. And the fact of the matter is, that was about 25 years ago. the advances that have happened in biochemistry over the last 2.5 decades reveal even more evidence for design than I could have even imagined as a young graduate student. Now, when you talk about design of biological systems, if you're familiar at all with philosophy and the philosophy of religion, you're going to immediately think of this gentleman, William Paley, the British natural theologian, who in the late 1700s wrote a book called Natural Theology, where he argues that when you look at the structure of living systems, the structure of living systems suggests that there must be a mind that's responsible for life, and therefore that there must be a creator, God must exist. And of course, Paley's argument is the famous watchmaker argument. In Paley's day, a watch was the pinnacle of engineering achievement. And so Paley argued that when you look at a watch, it has certain properties, it has certain characteristics. It's composed of a number of parts that are framed together, as Paley would say, to accomplish a purpose. And those parts interact in a very precise, deliberate manner. And therefore, one would conclude that a watch requires a watchmaker because of these characteristics. And he argues that when you look at biological systems, you see those same properties, and therefore, biological systems must stem from the work of a mind. Here are the words that William Paley wrote. In crossing a heath, suppose I pitched my foot against the stone and were asked how that stone came to be there. For anything I knew to the contrary, I might suppose that it lain there forever. But suppose I found a watch sitting there in the heath and were asked how it came to be there. I should hardly think the answer I gave for the stone to be sufficient explanation for this machine. I would know that someone somewhere had constructed this device. Now, this argument hasn't fared very well over the centuries, and the primary criticism is that the logic that undergirds the argument is faulty. Well, I would actually disagree with that, because essentially Paley is reasoning using analogies. And we know how, we all reason using analogies. In fact, almost all the reasoning you do is analogical reasoning, where you're comparing things and then drawing conclusions based on those comparisons. Science is essentially based on analogical thinking, as is legal reasoning. So there's nothing wrong with the logic applied here. The only thing that you have to be careful of is making sure that what you're comparing has the appropriate similarity, and that the things you're comparing are relevant to the conclusion that you're drawing. And so Hume and other skeptics have argued that that kind of analogical reasoning breaks down because a watch and a living organism are so different from each other. And what we'll see in a few minutes is that that criticism is no longer valid. And the other criticism is that Darwin's theory of evolution explains the design that you see in nature, that it's apparent design, not true design. But I've written a couple of books where I've argued that the attempts to explain the origin of biochemical systems from a scientific perspective are flawed. In fact, I did a debate a couple of nights ago at Imperial College where we talked about that very issue. And I did a debate a little bit over a week ago now with philosopher Michael Ruse at the University of California, Riverside campus, where we addressed that issue. And in fact, that debate is online if you want to see more details about how one can respond to the challenge of chemical evolution. But what I want to focus on is, again, the positive case for design and the evidence that we've discovered as biochemists that allows us to reinvigorate and revitalize the watchmaker argument. And just as Paley argued a watch and living systems have similarities, what we've also discovered is that same relationship as biochemists. What's phenomenal to me is that as a biochemist, when I reflect upon the defining features of biochemical systems, what becomes readily evident is that those defining features are identical to those features that define human designs. In other words, as human beings, when we create, when we invent, when we design, when we make things, those things that we make, as Paley argued with respect to a watch, have certain properties that reflect the work of a mind. And biochemical systems display those very same characteristics that fundamentally define biochemistry itself. And yet these characteristics are manifested to a far greater degree in biochemical systems and in human designs. And I would argue that this is a reason to believe that life stems from the work of a mind. And I'm going to give you a couple of examples. One has to do with what are called molecular motors. Biochemists have discovered that proteins inside the cell, and proteins are these large, complex molecules that carry out different activities inside the cell. Biochemists have discovered that many of these proteins actually function like machines, like nanoscale machines. What's remarkable is that some of these machines bear an eerie similarity to man-made machines. And there's literally hundreds that we could talk about that have that similarity. I'm just going to give you one example, and this is the F1F0 ATPase. This is literally an electrically powered rotary motor. And so if you look at this diagram, this is a protein complex made up of probably, I'm going to guess probably about 50 or 60 individual proteins that interact to form this complex. There is the F0 part, which looks like a cylinder embedded in the cell membrane, and that F0 component has what are called motor proteins that take the flow of electrical current, and that current causes those motor proteins to engage that rod that sticks out of it, which is a rotor, and as that rotor rotates, there's a cam at a right angle that crashes into those blue and green subunits that are functioning like turbines. And those turbines, as they experience mechanical displacement, actually drive chemical reactions. And there's a stator that holds everything kind of in place, that provides the framework for the rotor to rotate relative to. But this is an electrically powered rotary motor that practically operates at 100% efficiency. And again, this is just one example of a long list of examples that we could talk about. And in a book that I've written called The Cell's Design, I have a whole chapter devoted to different types of molecular motors. Now, I think that this reinvigorates the watchmaker argument. If just as a motor requires a motor maker, these biochemical motors must require a mind. Now, there, of course, are critics who have challenged that view. One of them is Massimo Pigliucci, who's a philosopher of biology at the University of Tennessee in the United States. And he argued that when scientists talk about proteins having machine-like properties, they're using metaphors as opposed to actually describing a real machine. And so people are mistaken, and they're exploiting this metaphorical relationship to make the argument for design as opposed to a real relationship that exists. And in effect, this is the same criticism that David Hume leveled against the watchmaker argument. What's interesting in light of that criticism is the fact that there are engineers and scientists who are trying to build what are called nano devices. These are molecular scale machines, and one big problem is how do you generate controlled motion in those machines? And it turns out that a number of scientists have suggested that we can just simply use these molecular motors found in the cell, purify them, and interface them into our nano devices. And a very famous experiment was done in 2000 as a proof of principle showing that this indeed could work. So the point here is that while Pigliucci is making that argument, the fact of the matter is technologists are using these machines literally as machines. So to deny that these are literal machines is really an absurd position to take in light of the work that's been done. So these really are machines in every sense of the word. Now, another place where you see, I think, an even more astounding similarity between biochemical designs and man-made designs has to do with what are known as the information systems inside the cell. At its very essence, biochemical systems are information systems. And there are two very important classes of molecules, nucleic acids, like DNA and RNA, and proteins that are information harboring molecules. And that information exists in the subunit sequences that make up the molecule. So this is a cartoon showing just a very small segment of the DNA molecule, and it's essentially two molecular strands that align in a parallel fashion, and each of those strands is built by linking together smaller molecules in a head-to-tail fashion. And those smaller molecules, there's 4 different molecules that are used to build DNA and RNA. They're called nucleotides, and they're abbreviated A, G, C, and T. These are called sometimes the genetic letters. And it's the sequence of those genetic letters that contains the information that the cell uses to build itself and to direct its operation. Some people refer to DNA as the blueprint of the cell, or the blueprint of life. But it's essentially an information harboring molecule. And the information in DNA is used by the cell to build proteins. And proteins, too, are information harboring molecules. And that information is found in the amino acid sequence that is used to build proteins. And so there are information theorists who study problems in molecular biology who have noted that there is a provocative relationship between human language and the information systems in biochemical systems. And so, for example, with respect to proteins, the sequence of amino acids are like the letters that are used to make words. And just like all letter combinations don't make intelligible words, all amino acid sequences don't make functional proteins. So only certain amino acid sequences make functional proteins. And then those proteins are working together to form complexes, which are like combining words to make sentences. And those sentences can be used to construct paragraphs, and those protein complexes work with other protein complexes to carry out metabolic operations. And so there's this language analogy between biochemical systems that is a genuine relationship and human languages. And that's an astounding analogy, I think, that again shows similarity between human constructs and man-made designs. There's even another more provocative analogy, and that has to do with how computer systems function and how biochemical systems function. There was a computer scientist a few years ago now at the University of Southern California named Gerald Adelman who recognized that the proteins that manipulate DNA are functioning as Turing machines. And a Turing machine is an abstract machine invented by the British mathematician Alan Turing. And this machine, this abstract machine, forms the theoretical framework for how computer systems function. And so Turing, who's considered the father of computer science, basically figured out how to again build or how to perform complex computations using again these abstract machines. But inside the cell, you've got literal Turing machines that are performing very simple operations that combine together to form very complex metabolic processes involving DNA. And scientists literally are taking that insight and are now looking to build computers around the DNA molecule using enzymes from the cell. That to me is rather mind-boggling, but again, it highlights the similarity between man-made designs and human designs. Another interesting characteristic as well, that again is an analogy to computer systems, has to do with the structure of DNA itself. Built into the structure of DNA is something known as an even bit parity code, which is a technique used by computer scientists to detect error in data transmission. And so again, we see another analogy between a computer design and how biochemical systems are structured. This to me is extremely provocative. Now I'm going to make one other point, and then I'd like to turn the floor over to you to give you a chance to ask some questions, and that has to do with the genetic code. The heart of the information systems inside the cell, and consequently the heart of biochemistry itself, is something known as the genetic code. This is essentially a set of rules that relates information in DNA to the information in proteins. And what's astounding is that these rules appear to be exquisitely designed. They're designed in such a way to minimize error that might happen if a mutation takes place in the DNA. And so the genetic code, which is universal, that is, all organisms on the planet have the same genetic code, is exquisitely optimized. This is a cartoon showing a depiction of experiments done by researchers who estimated the error minimization capacity of random genetic codes, which fall underneath that Gaussian distribution there in the red. And the code in nature is shown at the far right as an outlier. The code in nature seems to be unusual, and it has this extreme error minimization capacity. It is optimized, and the optimization is extreme. Simon Conway Morris, in his book Life Solutions, said this: the genetic code found in nature displays eerie perfection and startling evidence of optimization. And the fact that you see that level of optimization in that system, which fundamentally defines life itself, to me also points to the work of a mind. I could go on and on and on and on and on and talk about arguments that independently point to the work of a creator from the structure of biochemical systems, but when you pull them all together as a weight of evidence, there's even a much more powerful case that one could make. I believe that the design argument, based on discoveries in biochemistry, has taken on a new life of its own, And I think it's worth your time to, as people interested in apologetics, to spend a little bit of time understanding some of the arguments that have been made using biochemistry. I'm going to very quickly make one other point, and then I'll go ahead and wrap things up. Now, there is a new area in biotechnology that is really very exciting and also potentially very controversial, and that is an area known as synthetic biology, where scientists are literally trying to go into the laboratory and create artificial cells. And even a decade ago, the prospects of doing this would have been absurd. But we've learned so much about how biochemical systems operate, and we're able to manipulate these systems with such extraordinary detail that we now are on the cusp of having the technology to actually go in the lab and create artificial cells that are going to function like genuine life forms. Now, this raises all kinds of questions. But one about should we play God and things like that, is this safe? Very important questions. But to me, this work in synthetic biology is extremely powerful, because what this work demonstrates is that intelligence is required to take chemicals and to form those chemicals into an entity that begins to assume the properties of life. When you look at what is required to do this work, to create artificial cells in the lab, what you're immediately impressed with is how ingenious the researchers are. They develop these very sophisticated, elaborate strategies that just bespeak ingenuity. They develop incredibly sophisticated protocols to execute that strategy. It's some of the best minds in the world working diligently to bring about, again, the creation of entities that begin to assume the properties of life. Let me just talk about one example, and that would be an enzyme that was built from scratch. This is work published in Science in 2008. This is an enzyme built from scratch by a team of scientists, and it was designed to carry out a chemical reaction that isn't typically found in biological systems. And I'm not going to go into details here. I have a book called Creating Life in the Lab if you're interested in looking for the details. But in order to produce a single enzyme, not even something that would even remotely resemble a life, just one of the molecules that you would need in an artificial cell, it required, again, a sophisticated strategy. They had to, I'm going to talk a lot of chemistry right here for a minute, and don't worry if you don't understand the details, just get the big picture. They had to model the transition state. They had to figure out how to stabilize the transition state. They had to design an enzyme active site, then construct what's called the protein scaffolding, and then they had to fine-tune the enzyme in order to produce an enzyme that functioned only marginally as well as enzymes that you typically see in nature. This required a team of quantum chemists, computational chemists, protein engineers, biochemists, and molecular biologists. They utilized hundreds of hours of supercomputer time to design the protein and the enzyme active site. They had to rely on databases of protein structures that had been built up over decades and decades and decades of study. And then again, it took highly skilled scientists using sophisticated laboratory equipment to carry this out. That is, they demonstrated, I think in a very elegant way, that intelligence is required to bring life into existence. And this is not, this is an empirical observation. This is not an argument for design. This is an empirical observation. And this is just simply typical of the type of work happening in synthetic biology. So again, the 2 points that I made this morning are this, that the Christian worldview is perhaps uniquely compatible with the preconditions required for the operation of science, and that recent scientific advances support Christian theism, whether those advances are coming from astronomy or whether they're coming from biochemistry. And so I think it's completely rational to be a person who is a person of faith, who embraces the historic Christian faith, and a person who is a scientist. We live in a world that's dominated by science and technology. And in a world that's dominated by science and technology, those discoveries that are happening in science, those advances that are happening in technology affirm our faith and can be used to demonstrate to non-believers, again, the credibility of the Christian faith. And this is a wonderful bridge to ultimately introducing people to the Christian faith, because everybody has interest in what's happening in science and technology.
I believe that one of the requirements of building a scientific theory is that it is necessarily so, of necessity. What is the parallel in the kind of Christian theism approach to science?
I'm not quite sure I completely understand what you're getting at with that question. I'm sorry. Are you saying that when a scientist develops a model, that model is necessarily so? That is, there's no other possibility except for that model. Is that what you're saying? Yes. That's a really good question. And one point that I would like to make is that the arguments that I've made this morning, or the way that I've structured these arguments, is that they are philosophical arguments that are being informed by science. And so what I'm trying to do here is not present a scientific theory as such. Now, I do believe it's possible to actually develop a scientific model that is essentially based on a design or a creation paradigm. In fact, one of the things we're doing at our organization is attempting to do that very thing. And in a couple of books that I have here, Who Was Adam and Origins of Life, we actually present a scientific model for the origin of life and for human origins derived from a biblical worldview. So I think it's possible, because then at that point you're saying, okay, here are my ideas, here are the predictions that logically emanate from the ideas, and here's how we can test them. And so it functions now as a scientific theory. Now, what you point out is very much true, that the ideal is to have a theory that is uniquely able to explain the observations. Unfortunately, that is a very rare thing. And the people who make history in science are people who devise those special experiments that demonstrate the truthfulness or the validity of one theory and eliminate all other theories. And those are done. There's a handful of theories that do that. And so the idea is that we could, at least in principle, if that's the desire to present a scientific theory that's built around design or creation, we can very much do that, employing the methodology of science. And then what we need to do is to look for ways in which we can discriminate our model from competing models. And it's easier said than done. And in fact, the criticisms that we've received by scientists who have seriously looked at what we're trying to do, not scientists who are just criticizing off the cuff, is that they are appreciative of the fact that we're trying to do that, take that approach, but they don't feel like we've developed the discriminatory tests. But that's a problem that plagues science in general. Excellent question, though.
I noticed on one of the slides earlier the words irreducible complexity.
Can somebody raise, I'm not sure. Okay, there you go. I just like to be able to, thank you.
That takes me back to the book I read some years ago, Darwin's Black Box,
right,
which used, as I recall, the example of the human eye as an example of irreducible complexity, and has parallels with the chemical motors you were talking about earlier. As I recall, the atheistic response to that was to argue that, oh no, that can be explained by multiple generations. Yeah. For example, the eye of the Nautilus is an early form of human eye. It's just less formed. What strategies might Christians put forward to support the Christian worldview against that?
Yeah, that's a great question. And one thing that I'm somewhat concerned about as a biochemist is that we tend as Christians, and we all are guilty of this. I could be talking in a mirror now, so please understand me. We tend to hear arguments that initially we think to be very good arguments, and we latch onto those arguments, and then we refuse to let go, as opposed to trying to build a much more comprehensive case. And so I've met many Christians who feel like if the case for irreducible complexity is refuted, the whole case for design goes down the drain. Not the case at all. What we need to do is come to the table with a comprehensive strategy where we're using weight of evidence. And so one of the things I'm working on is how do we develop a comprehensive design argument? And one pillar of that argument is to criticize or the evolutionary explanation, focusing, I think, on the origin of life. And I think you can make very good criticisms, but many people just stop there. And I think there's other pillars that we need to put in place. For example, we need to argue using analogies. So I've introduced this idea of revisiting William Paley's approach. Now, if you have those two lines of argument going, you've got a much stronger case. The third line of argumentation is what I mentioned already, where synthetic biology is going to help us develop a third independent line of argument for design. And then I believe there's a fourth line or pillar that we could use, and that would be looking at how the designs in nature are actually inspiring human designs. This is called biomimetics. And so when you bring all those four lines of reasoning together, you've got a very powerful weight of evidence. And so the problem I have with the irreducible complexity argument is not that biochemical systems are not irreducibly complex, they are. It's the way that you frame it. Everybody is so concerned about Darwinism that I think we get obsessed with trying to refute Darwinism as opposed to making the case for design. So the way Michael Behe, who I respect very much, the way Michael Behe frames that is evolution can't explain irreducibly complex systems, therefore they must be designed. And all it takes is one example of somebody demonstrating plausibly how that could happen. The whole argument goes down the drain. And I think there are scientists who have done something very close to that if they've not accomplished that. What I like to do is say, that doesn't matter. Irreducible complexity is a characteristic of human designs. So if we see biochemical systems and they're defined by irreducible complexity, that's at least suggestive that they very well may be designed. And that piece of evidence, along with all these other characteristics that suggest design, along with some legitimate challenges we can bring to chemical evolution, along with the work in synthetic biology and biomimetics, when we pull it all together, whether irreducible complexity stands or falls is immaterial in terms of the way that it's typically argued. It still can be part of our argument, but it doesn't have to be the sole piece of our argument. So we need to be very thoughtful about the strategy that we're employing. And you actually gain a lot of credibility when you advance an idea with a non-theist, and if they're able to show, okay, you've got weaknesses in your idea, if you're able to say, yeah, I think you've got a point here, but what about all this other piece of evidence? So if you argue comprehensively, you're able to concede ground, but still not compromise your argument.
Thank you, Dr. Rana. I think your position is very nuanced and interesting and very good. So my question would be, how much of the world's complexity do you think is accounted for by natural selection?
I don't believe the origin of life can be explained through any kind of evolutionary means. And with regard to the idea of biological evolution, I'm skeptical of the aspects of the paradigm, but not the entire paradigm. I think Darwin got it right when he demonstrated that species are not fixed, so species have the capacity to adapt. I think speciation happens. I do not believe you can extrapolate that speciation to large-scale biological changes. So when it comes to how does one major group generate another major group, that's where I think the theory of evolution is really on, in my opinion, on shaky ground. But when it comes to, basically fine-tuning or varying an existing design, I think evolution does a wonderful job of accounting for that. I also believe microorganisms evolve. There's ample evidence for that. So to me, it's not a whole-scale rejection of biological evolution, but really chemical evolution and what people might call macroevolution. But exactly where that boundary is, I'm still working that out myself. But I do think there is a real boundary. And as you go from organism to organism, that boundary may actually move, because remember the categories we have for classifying organisms are man-made constructs. And so, for example, a family among mammals may not be the same thing as a family with regard to a particular group of invertebrates. Those categories are not transferable, or there's not a uniform criteria for those categories. We're running out of time. I'm going to try to go quickly. We still have about 5 minutes, so. I'll let you choose. There's too many.
Yes, praying works. Cool. Thank you for your talk. I just had a question about the role of information. It's just something I've been thinking about for a while. Like, kind of, what is information? How do we detect it? And I guess my fear is that we can end up kind of begging the question for design. So, say. You put up the analogy of, or potential analogy of the information in biochemical systems and in natural human language. I think an important point of this analogy, though, would be that, say, when I read words on the screen, the physical markings or digital markings, as it might be, kind of saying Premier Christian Radio, aren't actually literally causing like an informational reaction in my mind. Like it's more of a semantic or mental thing. Whereas I think in a biochemical system, there is a literal physical causation going on. So what makes a physical system just physical causal interaction, and what makes it also have informational content? Is it just that, oh, we know there's a mind involved, so that means it's information, which would be question begging for the argument for design? Or can we detect... Right. Can we detect information?
Yeah, well, and I'll point out that those relationships are relationships that information theorists who spend their careers studying information theory have actually identified. So they're the ones who are actually saying this is that relationship. And your point is a very, very, very good point, which I actually think makes the case for biochemical design even more profound. Is you're right, when it comes to like a word written on the screen, like let's say cat, C-A-T, whether it's written on that screen and being projected, or I would write it with a marker or write it with a crayon or spell it out with stones on the ground, the physical medium doesn't matter. Okay, but in biochemical systems, you've got the physical medium actually does matter. But what you'll discover is as you begin to penetrate the biochemical systems, you realize that those systems are optimized to actually harbor that information. So the genetic code is it's an abstract entity, but it's also physically manifested in what are called the anticodons of transfer RNA molecules. But when you begin to examine the chemistry that's involved in how the codon-anticodon binding happens at the ribosome, what you realize is that these things are extremely optimized in such a way to make this possible. So the argument for design is even more profound in that the physical medium harboring that information is actually integral to that information functioning and the optimization of of how those information systems operate. So I think it actually makes the case for design stronger, not weaker. But your point is a very good point. And I've seen atheists actually use that to dismiss the information argument, but ironically, they've actually, again, have laid a trap for themselves.
I just wanted to ask how, within your model, you would account for sort of defects within organisms, like design defects. So, for example, the evolutionary biologist Francisco Ayala has pointed out, for example, human beings have an appendix. We don't really need an appendix, or we have the vestiges of a tail, or we're not optimized for standing upright. How would you deal with that within your model?
Yeah, great question, and I got 30 seconds to answer it, of course. If there's a challenge to the design argument, it's that. It's what appear to be bad designs in nature. And in fact, in my book, The Cell's Design, I have a whole chapter devoted to that problem, and I've written extensively, and there's a lot of articles on our website about so-called bad designs. And very quickly, just in a general sense, first of all, oftentimes when people declare certain systems to be bad designed or poorly designed, they tend to be systems that we really don't fully understand. And the declaration of those systems being poor designs is based on authority of that individual making that declaration, not on actual demonstration of it. And oftentimes when we learn more about the system, what we thought was a bad design turns out to be an elegant design. Now, also there are designs in nature that may appear to be bad designs, but more appropriately are suboptimal designs. And if you are familiar with engineering, you know that if you're trying to engineer very complex systems that do a number of different tasks, you cannot optimize each individual component of that system, but rather you have to intentionally sub-optimize the components so that there's overall optimal performance. That is, you're confronted with trade-offs. And a lot of bad designs are actually trade-offs, more appropriately. And again, I think it's also reasonable to think there very well could be some examples of bad designs in nature because, again, optimal designs are going to degrade simply because we live in a universe where entropy operates. So the presence of bad designs isn't necessarily a showstopper in and of itself. But that's a very good question, and if you're going to make the design argument, you better be ready to respond to that challenge.